MC20 will equip the new 90-degree V6 gasoline engine 100% made in Modena. The V6 engine is a dry sump twin-turbo engine with a total displacement of 3.0 liters, capable of 730 Nm of torque and a peak power of more than 620 horsepower at 7,500 RPM. Without any doubt, the core of the engine is the innovative and patented twin-spark pre-chamber combustion system coupled with both a port and direct injection. This innovative system, fully designed and developed by Maserati engineers and skilled technicians, is able to meet the requirements of combustion stability, noise and drivability for passenger cars, providing at the same time an amazing improvement of efficiency and specific power, a key feature to bring the Tridente back to racing. To understand the origins of the engine of the MC20, we need to learn about the start of the adventure that led to the development of its innovative combustion system. The project began in 2015, linked to the pre-chamber technology developed for the F1 engines. A small team of colleagues designed and developed the prototype to evaluate the system potentials. As soon as the first prototype ran at the dyno, we realized that it was a success. The enthusiasm used to present the data cannot be mistaken. The first test car with the new engine arrived 2 years later, to add the thrill of driving the new version to the initial enthusiasm. From that point on, the effect was viral. This engine was going to be the engine to build. The initial team was then expanded and integrated with the propulsion system organization under the leadership of Gianluca Pivetti, with the aim of finding out whether an F1 technology could be adapted for use on production car, where you only have to miss a certification, emission or drivability target to slow down or even cancel the development of the whole project. Confirmation that the idea was feasible came in 2017, with filing of the international patent, and in January 2019, when finally, in response to the result presented, we were awarded the budget requested for the industrialization of the new family of V6 engine with the new technology exclusively for Maserati. Maserati was once again going to build its own engine, 100% made in Modena. First objective was MC20. But which engine are we talking about? To answer this, let's start from the car which will equip this engine. MC20, standing for Maserati Corse 2020. Elegant and comfortable to drive like all Maserati cars, but at the same time high performance, compact and extremely sporty. Every single requirement was fulfilled by the new 90 degrees V6 engine designed by the Maserati in-house high-performance propulsion team. The mid-mounted rear engine, with a dry sump layout. The favorite solution for this kind of supercar is a V6 twin-turbo with a dual injection system and a displacement of 3.0 liters. A compression ratio of 11:1, combined with a stroke of 82 mm and a bore of 88 mm, enables the engine to deliver 730 Nm of torque and a peak power output of 620 horsepower at 7,500 RPM, with specific fuel consumption of less than 290 grams times kilowatt-hour. Without a doubt, the core of the engine is the innovative twin-spark pre-chamber combustion system, composed substantially of 3 main components. The first one, the injection system, a combination of port, injection and direct injection with a fuel feed pressure of 350 bars, which has the aim to reduce noise at low revs, lower the emission level and improve specific fuel consumption. The second one, the pre-chamber, basically a combustion chamber placed between a central spark plug and the conventional combustion chamber, to which it's connected by a series of specially shaped holes. The last one is the side spark plug, a standard spark plug that provides backup to ensure smooth engine combustion in operating conditions when the use of the pre-chamber is not necessary. But let's take a more detailed look at the combustion. Near the top dead center, the main spark plug ignites an air-fuel mixture injected previously by the piston compression stroke in the pre-chamber, triggering a pilot combustion which is then propagated into the main combustion chamber via a series of properly designed jets. Observing this phenomenon from the outside of the pre-chamber, you would see a series of fire crests emerging from the jets of the breech-chamber instead of the traditional flame front propagating from the spark plug. The tip of the crests will then trigger multiple ignition areas, providing much faster, more uniform, more efficient combustion than with a conventional gasoline engine. So to sum up, the benefits of the breech-chamber system are a more efficient combustion and a less tendency to knock. These enable us to achieve an impressive improvement in terms of efficiency, which can then be used, depending on the application, to increase the performances, to obtain a better fuel economy, or for a combination of the two. However, these advantages are nothing new for the expert in the field. Similar results have been achieved in the past on experimental engines, but their development has always been halted due to a series of problems with the combustion system itself. On the one hand, this provides the benefit already mentioned before, but on the other, it suffers from problems of instability at low loads and noise level that impair its potential for use on road cars. It's in solving those very problems that our team has made the difference, as we are the first to develop hardware contents and engine control strategies that would maintain these original features unchanged while still meeting all the noise, stability and comfort requirements of a road car usage. Team competencies and the high degree of integration between simulation and experimental test on system components enabled us to work efficiently during the engine design process to achieve our goals, finalize the development, and proceed with the product industrialization. On the company's part, this process demanded a huge investment in terms of time and resources for the radical modification of its own plant to create the new engine development hub dedicated to the 100% made in Modena family of engines. Here we are talking about a whole new set of engine dynos, emission test dynos, inertia test benches, workshop and engine assembly areas, right through the powertrain test bench, a special test area used to develop and fine-tune the powertrain control strategies directly on the car. Last but not least, the production line. With such high technology standards, it was natural to choose the historic Via Menotti plant as the production hub to maintain a direct link with the engineers who had done the development work since the first day. The assembly line will have the honor of producing the engine that will be the first of a whole new family of innovative propulsion units, which on one side will be used in the entire range of Maserati vehicles, while on the other will bring the Tridente back into the world of racing, where the century-long Maserati story all began.